Dear students, this is the last class of the chapter Units and Measurement. So, I want to measure the length of this particular pen, for which I am going to use a device called the meter scale. So, using this I can measure the length of this particular pen. Now, using this scale, the least value that I can measure is 0.1 centimeter. What is the least value that I can measure? It's a 0.1 centimeter is the least value that I can measure. So, therefore, the readings are like 3.1 centimeter, next to that 3.2 centimeter, 3.3 centimeter and so on. I cannot measure the next digit here. Using this scale, I cannot measure 3.11, not possible. So, the least value that one can measure using any device is called the least count. So, the least count of the meter scale is 0.1 centimeter. So, that is the image of the meter scale. So, we have one more device called screw gauge. I can place this pen here in between, and then I can even take the thickness of this particular pen. I can measure how thick this particular pen is using this particular device. And the least value that I can measure using this device called a screw gauge is 0.01 millimeter, and this is called the least count of the screw gauge. I can make use of one more device called travelling microscope. Using this travelling microscope, I can again measure the thickness of this particular pen, and the least value that I can measure is a 0.001 centimeter. So, these are all called the least count of the various devices. We cannot measure any value lesser than this. That is what is called the least value. Okay. Now, greater the number of digits after the decimal. Listen carefully. Greater the number of digit after the decimal, more is the precision. We can say that the value is more precise. So, what do you mean by precision? Precision indicates the limit up to which the value can be measured. Limit, how many digits I can measure after. Greater the number of digits after the decimal, the value is more precise. So, with the help of all these devices, I am going to do the measurement. So, let me take some of the example here, so that you can understand what exactly that we are going to measure here. So, with the help of the various devices, I am going to take different readings. Okay. So, what I will do is I will use one device, and then I will measure the length. Let us take length is measured, and these are the different trials. I am going to measure it 3 times. A1 is the first trial, A2 is that of the second trial, A3 is that of the third trial. Okay. A1, A2, A3 are 3 readings measured using one device, same device. Okay. And once I measure all the 3 readings, I am going to take the average of that, average value. The average value is also called the mean value. It is also called as the true value. So, the mean value is nothing but this is the mean value. It is also called as the true value, or it is also called as the average value, average. How to find the average? Average is add all the values, that can be 3 trials, 4 trials, and divided by the number of trials. So, here in this case, since I have measured 3 readings, it is A1 plus A2 plus A3 divided by 3, and I'm going to get a value, and that value is called the mean value, average value, or is also called as the true value. Now, after measuring the mean value, we find that there is always a difference, between the mean value and the individual values. Correct? There is always a difference between the true value and the measured value. And this difference is called the error. So that is what this topic is all about, and we are going to discuss about the error in the measurement. So what is the error? So whenever we measure a particular quantity, that measured quantity need not be always equal to the true value. There is always uncertainty in the measurement. There is always uncertainty, and that uncertainty in a measurement is called as error. So what is error? Uncertainty in a measurement. It's not certain. It can be equal to the true value also, correct? But if there is a difference between the true value and the measured value, then we say that there is an error in the measurement. So that's why uncertainty in the measurement is called the error. So what is accuracy and precision? Let us take 5.7 is the mean value, or it is also called as the true value. I have already mentioned about it. So this is the mean value and this is the true value. Correct? Mean or true value, 5.7. And the measured values are 5.6. The other measured value is 5.8. The other value is 5.9. Now, if you see out of all these, 5.6 is very close to 5.7. 5.8 is also very close because the difference is only 0.1. See, here difference is 0.1, here also 0.1. But 5.9, the difference is more, it is 0.2. So, what is the accuracy? Accuracy indicates how close the measured value is to the true value. Out of these, 5.6 and 5.8 are more accurate than 5.9. Why? Because 5.6 and 5.8 are very close compared to 5.9. If I take next 5.10, now out of these, this is more accurate than this. So what is accuracy? Accuracy is a measure of how close the measured value is to the true value. These are measured value, this is the true value. What is true value means? It is the average, mean value, okay. And now when you compare, which is very close, and that value is said to be more accurate. And what is the precision? I have already explained precision, correct? Precision indicates to what limit the quantity is measured. Limit means how many digits that we can measure after the decimal. For example, 5.1, 5.11, 5.111. This is a more precise value. Why? Because after the decimal point, we could measure how many digits? 3 digits. Limit up to which, see, limit. The precision indicates what limit the quantity is measured. What limit? Up to how many digits we can measure. That is said to be more precise. This has nothing to do with the accuracy, or it has nothing to do with the mean value or the true value. If we are able to measure more number of digits using a device, then we can say that that particular reading is more precise. Hope you understood the difference between the accuracy and the precision. So this is the question that has appeared in 2015, that is, what is accuracy and what is precision. So what is the accuracy indicates? Accuracy indicates how close the measured value is to the true value, and precision indicates the limit, to what limit a value can be measured. So, that is called as the precision. Okay. So, precision indicates what limit the quantities are measured is called as the precision. Okay. So, what are the types of errors based on the cause, based on the reason? So, based on the cause, the errors are classified into two types. One is called as a systematic error. The other is called the random error. So, what is systematic error? The error due to the known cause. Known cause means a known reason. So, we know what is the reason why there is an error. So, such error is called as a systematic error. And what is random error? The error due to the unknown cause. So, we are not aware as what is the reason for the error. Such error is called as a random error. So, we use a weighing scale, to measure the mass or measure the weight. And when we use that weighing scale, so for example, if you are measuring some gold, you must have seen, they will use a digital balance, right, and they will place the gold over it. Imagine if there is some dust which is settled over the pan already. And when there is a dust which is settled, obviously we will come to know because of the reading, but if we are not aware of it, then it is called the random error. Error due to the unknown causes is called the random error. The error due to the known causes is called systematic error. The systematic error is of two types. The first one is called instrumental error. This error arises because of the faulty instrument. The instrument in which there is some fault. So, for example, if it is a weighing machine only, without keeping any object, if it already shows some indication or if it shows a reading of 0.1, when you do not place any objects over it, it should indicate 0, but it is showing 0.1. So, that means it is not calibrated, the instrument, there is some fault in it. So, such error is called as instrumental error. So, instrumental error arises because of some faulty instrument which we are using for certain measurement. The second type of error is a personal error. Now, this depends on the individual. It is different for the different person. And this error arises because of the lack of attentiveness or maybe because of the bad sight. So, without if there is a person having bad sight and without using any spectacles, if he tries to take the readings on a thermometer, then definitely he will be able to, he may not be able to read the correct temperature. So, that is the personal error. So, personal error arises because of the lack of attentiveness, because of the bad sight. So, these are the two types of systematic error. So, what is systematic error? Error due to the known cause is called systematic error, and error due to unknown causes is called random error. And systematic errors are of two types. One is instrumental error and the other is personal error. And this question has appeared once in the examination, that mention any two types of errors, mention any two types of error. So, basically you need to write systematic error and a random error. They have asked mention, so you do not have to explain anything, it is a 2 marks question. Types of error based on magnitude. Can we measure the errors? Yes, that is what we are going to learn here. So, types of the error based on the magnitude. So, what are the types of the error? The first type of error is called as absolute error, and that is what I am going to explain right now. So, please see the data which is already used. So, these are the 3 trials that we have measured, 3 trials, 3 readings, A1, A2, A3, and I am going to take the mean value of it, and that mean value, the mean value is called the true value or the average value. The mean value or the average value is also called as the true value, the real value. And then I can find the difference between the mean value, that is the true value, and the individual measured value. And that difference is called as the absolute error. So, what is absolute error? So, absolute error is the difference between the true value and the individual measured value is called as the absolute error. And we denote that by a symbol. We use a symbol delta for it. Absolute, this is absolute error. The symbol I will write delta A1. This is the absolute error of the first trial. Delta A2, delta A3. We use a delta always whenever we find the difference. Okay, we use the symbol delta whenever we find the difference. We use the symbol delta. So here, what is delta A1? Absolute error of the first trial. What is delta A2? Absolute error of the second trial. What is delta A3? Absolute error of the third trial. And for a given instrument, the least count is taken as its absolute error. In a given instrument, the least count is always taken as its absolute error, because that is the least difference that is possible between any two readings. Okay, that is in the case of instrument. Okay, so hope you have understood absolute error. So what is absolute error? It is the difference between the true value and the individual measured value is called as the absolute error. And now what I will do is I will take the three absolute error, delta A1 plus delta A2 plus delta A3. Then I will divide by 3. So now what I am going to get? These are absolute errors, correct? And when I add them and then divide by 3, I will get the mean absolute error, that is the average of the absolute error. What is the difference between AM and delta AM? What does AM stands for? True value or the mean value. What is delta AM stands for here? It is the mean. Moment there is a delta, it has to be absolute error, right? So it has to be mean absolute error. So what is delta AM? It is mean absolute error. Okay. So that's called mean absolute error. This is the mean value or the true value. This is the mean absolute error. So absolute error we measure by finding the difference between the true value and the individual values. And if we take the average of all the absolute error, then we get mean absolute error. Let us see what is the second type of the error. It's called the relative or fractional error. Relative or fractional. So relative error or fractional error is I will write the equation, then you can tell me how to define it. Relative error or fractional error is the ratio of mean absolute error to the mean value. How do we define relative or fractional error? It is the ratio of mean absolute error to the mean value, or mean value is also called as the true value. So this is the second type of error which we can measure, we can find it. And the third and the last is called as the percentage error, which is very simple. The relative error or the fractional error expressed in terms of the percentage. You have to just multiply by 100. Now this is called the percentage error. So how do you find the percentage error? So once you know the fractional error, just multiply by 100, you will get the percentage error. So fractional error or relative error expressed in terms of the percentage is called the percentage error. So these are the three types of error based on the magnitude. Which and all? Absolute error, relative or fractional error, and the third one is percentage error. How do we measure the absolute error? The difference between the true value or the mean value and the individual measured value is called as the absolute error. And the average of that will give you the mean absolute error, mean average. Ratio of the mean absolute error to the mean value is called the relative error or fractional error. And then the fractional error expressed in terms of the percentage is called as the percentage error. So, while multiplying, while dividing, while adding, while subtracting, so you need to follow certain equations in finding the fractional error or the percentage error, and that is what we are going to learn next. So, magnitude of the errors. So, see the equation. So, these are important. Right. So, we have a table here. A is one quantity, measured quantity. B is another measured quantity. We want to add them. For example, mass, 1 kg mass, 2 kg mass, adding, that becomes a 3 kg mass. I can even find the difference between the masses. 1 kg, 2 kg, difference is 1 kg. So, this is while adding and while subtracting a physical quantity, and this is what you get after adding. So, Z is the value which we obtain after adding two quantities, and when you add two quantities, it has to be identical. You cannot add mass with the time, you cannot add force with the velocity. You can add two velocities, two forces, two mass, two time, it has to be identical. Okay, so that is most important when it comes to physics, right. So, while adding or subtracting, what is the absolute error? So, Z is equal to A plus B or minus B. I have combined two equations together. Okay. When Z, so let me write here this side. So, Z is A plus or minus B. Okay. So, that is the equation while adding or while subtracting. Then the absolute error is always given by sum of the absolute error of the individual quantity. The absolute error is equal to sum of the absolute error of the individual quantity, delta A plus delta B. This equation is valid for both addition as well as subtraction. Even if while subtracting also you have to add their absolute error. Now, how to find a relative error? What do you mean by relative? Relative error means it is a delta Z by Z. Am I right? Correct, no? Delta Z by Z. Delta Z is absolute error divided by the true value, which is Z. What is delta Z? Delta Z is here, correct? So, write that. That is delta A plus delta B. Correct, no? Delta Z is nothing but delta A plus delta B. What is Z? Z is here, A plus or minus B. A plus or minus B. So, this is how we can find the relative error. Hope you have understood. So, whenever we add or subtract quantities, absolute error, the net absolute error is equal to absolute error of the individual quantity. Okay. And then the fractional error is the ratio of the absolute error to the true value. That is how we measure whenever we add or whenever we subtract quantities. Okay. So, the equation is already there, you can check that. Fine. Delta Z by Z is equal to delta A plus delta B by A plus B. Okay. Next, whenever we multiply or whenever we divide quantities, whenever we multiply or whenever we divided quantities. That is, Z is equal to A into B, or Z is equal to A by B. This rule is only while adding or subtracting quantity. While multiplying or while dividing two quantities, the fractional error delta Z by Z is equal to sum of the fractional error of the individual quantity. Remember, this equation is completely different from what I have written here. Okay. So, while multiplying or while dividing two quantities, the fractional error or relative error is equal to sum of the relative error of the individual quantities. See that. Delta Z by Z is equal to delta A by A plus delta B by B. Okay. See, there is a difference between this and this. They are not same. Clear? Then, how to find absolute error? It's very simple. Absolute error is nothing but delta Z. I wanted only delta Z. So, what is delta Z? Take the Z to this side. So, you will get Z into delta A by A plus delta B by B. So, this is how you can find the absolute error. That is while multiplying, dividing only. Hope you are clear with that. Okay. Now, whenever we have a quantity having to the power n, like we do have equations, kinetic energy is equal to half mv square, there is a power. So, whenever there is a power, then how to find the error? So, Z is equal to a to the power n. Then, the absolute error in Z, delta Z by Z, is equal to n times delta A by A. Delta Z by Z is equal to n times, whatever the power is there, you just multiply that. Okay. So, that means the fractional error is always n times the fractional error of the individual quantity. So, that is what the equation delta Z by Z is equal to n into delta A by A. Then how to find the absolute error? Just rearrange, delta Z. Delta Z is equal to, see, delta Z is always the absolute error. Okay. See, absolute error is the delta Z is equal to, take this Z to the other side, it becomes nz, then delta A by A. So, that is what the equation that you get. So, hope it is clear regarding the rules to be, or the equation to be followed while calculating the magnitude of the errors. Okay, now whatever the error that I have given here, formula is for absolute error and for relative error. How about the percentage error? Percentage error is very simple. Once you get the answer using this formula, multiply by 100, you will get the percentage error. If the absolute error is 0.7, absolute, not absolute error, sorry. If the relative error is 0.7, then how to find the percentage error? Multiply 0.7 into 100. You will get 70. So, 70% is the percentage error. Are you clear? So, this is how we can calculate the magnitude. I will give you more formulas here. So, one more formula I would like to add here. If Z is a to the power n and b to the power m is there, like this. Okay. Not just one, there are two quantities. Then delta Z by Z is equal to, delta Z by Z is equal to n times fractional error in A. Remember, relative error and fractional error means the same. Okay. N times delta A by A plus m into delta B by B. So we have used the power formula here, n times delta A, and then this is multiplication, correct? A into B multiplied. So whenever there is a multiplication, we have to add the fractional errors. So this is a formula combining z is equal to a to the power n and then combining z A into B. So this is how we can calculate the fractional error. If you want absolute error, then take z to the other side, you will get delta z here. That will give you absolute error. If you want percentage, multiply by 100. So hope all the formulas are clear. So I'm going to solve problems based on this. So by then it will be more clear. So let's try one numerical. Okay, this is the question. Find the fractional error in z if z is a cube b to the power 1/3 by c square. Find the fractional error in z if z is a cube b to the power, that's cube root, and then c square. So this is the question that is given. I will go back to the table so that you can make use of the formula. Check this here. A cube, that means I have to use this formula z a to the power n format. A into b, I have to use even this. Then there is a division, divide, correct? I have to use this. And they have asked, what is the fractional error? Find the fractional error. So fractional error means I have to use these formulas. Correct? So delta z by z. Correct? No, this is the fractional error, relative error. Ratio of absolute error to the true value. A cube, I have to use this format, right? Z equal to a to the power n is always n times. So 3 times delta A by A. That is for this first. Whenever there is a multiplication, we have to always add the fractional error. So plus, what is the power? Cube root b to the power 1/3. 1/3 is like power n. So 1/3 of a delta b by b. Are you following, students? Then plus, even while dividing, listen carefully, even while dividing, we have to add the errors. Even while dividing, we have to add. So that means, even though it's a division, I have to add, correct? What is the power? 2 times delta C by C. Are clear? Even though it's division, see, even while dividing, we have to always add, because errors, they don't get cancel each other, they'll get added up. Correct? If we make 2 mistakes, correct, mistakes will get added up, they don't get cancel each other. There's nothing like positive mistake and negative mistake. The mistakes are mistakes only, right? So that's why. So that's it. So this is the answer to that particular question. They've asked find the fractional error. So here I have used z is equal to a to the power n rule, and then I have used the multiplication rule. While multiplying, we add the errors, and then I have used the division rule. While dividing also, we have to add the error, but you have to multiply with the power that is given. I hope now it's clear regarding how we have to use the rules. Correct? Okay, so let's go back to the question. So this was the question asked, find the fractional error. Fractional error means ratio, relative error, that's what we have found, correct? We found delta Z by Z. Delta Z by Z is equal to 3 times the delta A by A plus 1/3 of delta B by B plus, here it was a C square, correct? No? Right. So 2 times delta C by C. Okay. So very simple. So it's either 1 mark or 2 marks question. So let's try one more numerical now. Okay. See the statement. The resistance R is given by V by I. R is equal to V by I. So you know that is from the Ohm's law. Okay. Very important relation. So that's how we read, you know, V is equal to IR. Very important relation. Easy way to remember. Okay. Right. So V is equal to IR or R is equal to V by I from the Ohm's law. Now the resistance R, where V is given, V is 100 plus or minus 5 volt, you know, that is the unit of the potential. Then current I is equal to 10 plus or minus 0.2 ampere. Now here, what is this 100? This 100 is nothing but the voltage V 100 by current I, how much? It's a 10 ampere, 100 volt, 10 ampere. So 100 by 10, how much is that? It's a 10. It's a resistance. What is the unit of the resistance? So that's in ohm. So we have found the resistance. But what we have to calculate? Find the percentage error in R. What do you mean by percentage error? Percentage error is nothing but delta R by R into 100. This is what we have to calculate. Percentage error, delta R by R. Delta R by R will give you what? The fractional error, relative error. Relative error expressed in terms of the percentage is called percentage error. That's what we need to calculate. So we have found R. We have found R here, correct? And now we have to find delta R by R and then multiply by 100. Okay? Yes. So now here R is given. This is R. And R is equal to V by I. So recall the formula. Z is equal to A by B. When Z is A by B, what is the fractional error? Delta Z by Z. Delta Z by Z is equal to delta A by A plus delta B by B. And there we get the value of the fractional error which is required here. So that's why I will use that formula. R is equal to V by I is nothing but delta R by R. Delta R by R is equal to delta V by I, delta V by V plus delta I by I. I have used this particular rule in finding delta R by R. What is a delta V? Delta V is nothing but absolute error. And absolute error is, I have already told you, it is the least count of the device. And they have already given it. Can you see that here? It's 100 plus or minus 5 volt. So 5 volt is the least count of the device. Which device is used to measure voltage? It is a voltmeter. So therefore the least count of the voltmeter is given 5 volt, and that 5 volt is nothing but the absolute error. So therefore this delta V is nothing but 5 divided by the value of V, which is 100, plus delta I here 0.2 ampere. Which device is used to measure the electric current? It is an ammeter. So what is the least count of that? It's a 0.2. 0.2 divided by I is 10. So this is equal to, what is 5 by 100? 5 by 100 is 0.05. Very simple, we don't need a calculator for that. What is 0.2 by 10? That's 0.02. 0.02. So you add them, how much? 0.07. So I have found delta R by R. Delta R by R. Correct? So the value of the resistance is 10 ohm. Resistance is 10 ohm. The value of the fractional error is a 0.07. So therefore, delta R by R itself is a 0.07. Correct? This is 0.07. delta R by R itself is 0.07. Multiply by 100. How much will you get? 7%. So what is the error? Percentage error? It's a 7% is the percentage error in the measurement of resistance. So therefore, when you write the value of the resistance, you can write R. How much we have measured R? R is equal to 10 ohm. We can write like this: 10 plus or minus 7%. So this is the value of the resistance. Actual value of the resistance is a 10 ohm, and the percentage error is how much? 7%. Why do we measure plus or minus 7? Because we don't know, it can be error, because whenever we measure the error, the variation is either 7% more than the value of 10, or it can be lesser than the value of 10. That's why we write plus or minus 7%. So hope you have understood the method of finding error. So we'll try one more numericals based on the error. And students, I hope you have started revising the topics, because after a few days there will be test. And the duration is 1 hour, I have already mentioned it. The test paper will be given at sharp 10 o'clock, and by 11 you have to finish it, and then click the images in the low resolution setting of your camera, and then forward that to my number. And then do not copy from the material and then write. It's of no use. If at all you are planning to copy, then my suggestion, my advice, my request, don't try the test, because you will not achieve anything by copying from the study material and then transferring to the sheet and then sending it. Okay. What you will achieve? You will achieve how effectively you can copy. That's what you learn in life. So that's why my advice, my request, my suggestion, that do not copy. Whatever that you have studied, do write sincerely and then submit the paper. Even if you score a lesser mark, doesn't matter, but copying is not the right method of writing the test. Hope you are following what I am talking about. Okay, so we are going to solve one more problem, and this will be the last problem of this particular chapter. Is this the last, or we have one more? Yes, there is one more. So we'll solve this one. The temperature of a body are given T1, I will write. It's 20 plus or minus 0.1 degree centigrade, and the other temperature T2, 30 plus or minus 0.2 degree centigrade respectively. So this is one of the temperature measured using one thermometer. This is another temperature measured using another thermometer. Okay. What is the rise in temperature? What do you mean by rise in temperature? Rise means increase in temperature. Increase in temperature is always greater temperature minus the smaller value, correct? That's a T2 minus T1. What is the T2 here? T2 is 30 degree minus T1 is a 20 degree. So it is a 10 degree centigrade. Now we are subtracting two quantities. Recall the rule, while subtracting, Z is equal to A minus B. While subtracting, the absolute error is always equal to sum of the absolute error of the individual value. This is the rule while adding or while subtracting. So that's why here this is a T2 minus T1, which I'll write it as a T. So therefore delta T is equal to delta T2 plus delta T1. Remember, even though we are subtracting, we have to always add the absolute errors. Keep in mind. So that's why delta T is equal to delta T2 plus delta T1. Even though we are subtracting, we have to add the errors. What does delta T2 and delta T1 means? Delta T2, delta T1 is nothing but the absolute error, which is nothing but the least count of the device. And least count of the device is always, it will be given along with the value. See, this is the least count of T1. first thermometer. This is the least count of the second thermometer. That means using the first thermometer, one can measure a least value of 0.1 degree centigrade. Using the second thermometer, one can measure a least value of 0.2 degree centigrade. So basically have to add these two values. So delta T2 is a 0.2 plus 0.1, that will give you 0.3 degree centigrade. So therefore, what is the rise in temperature? The rise in temperature is a T, that is equal to 10 degree centigrade, that is the value, with the, what is the error? Plus or minus 0.3 degree centigrade. So this is how we write the final answer. So therefore, the change in temperature is 10 degree with this much error. Actual change is 10 degree, but there is some error. How much is that error? The error is plus or minus 0.3 degree centigrade. Okay. So here we have used the rules while adding or subtracting two quantities. Right. So this is definitely the last numerical of this particular chapter. So go through the statement of the question. The statement is if the percentage error in the measurement of mass and velocity is 2% and 3% respectively. They have given the percentage error in the measurement of mass. So delta m is the absolute error, delta m by m is the fractional error, and multiply by 100. That will give you the percentage error in the mass, and this is given how much? 2%. And velocity, that is delta v, absolute error divided by v, relative error into 100, percentage error, that's given 3%. Okay. Then what is the percentage error in the measurement of kinetic energy? So kinetic energy given formula, K is equal to half mv square. So here we have the rule to be applied is a product rule as well as the power rule, power. So let's write the absolute error, delta K by K, correct? That is the absolute error. Half is a constant, right? This is not a measurement, so therefore there is no error involved, we don't write that. Delta m by m, fractional error in the mass, plus twice delta v by v. So I have used the product rule. While using the product rule, the fractional error to be added, and whenever there is a power, multiply by the power. But this will give you what? The fractional error, but what we wanted the percentage error. So for which I have to multiply by 100. Delta k by k into 100 is equal to delta m by m into 100 plus 2 delta v by v into 100. Correct? So I have multiplied by 100 throughout to write the percentage error. So what is delta k by k into 100 means? This is nothing but the percentage error in kinetic energy. That is what we have to calculate. Is equal to, what is delta m by m into 100? Delta m into m by 100 is given 2%. So this is 2 plus 2 into, that is this, 2 into, what is the percentage error in the velocity? That is given 3. So this is 2 plus 3 into 2 here, that's a 6. 6 plus 2, 8%. So that is the percentage error in kinetic energy. So this is one more illustration for the percentage error concept. So hope you have understood the concept called error. So learn this entire chapter as well as the previous chapter. So there will be a test this coming Sunday, and hope you have already started preparing. So my best wishes, and in my next class I am going to start the next chapter, which is chapter number 3, called motion of a body along a straight line. So it's a very interesting chapter. So hope you are watching the videos on a regular basis, and then if we are unable to understand any concept, feel free to clarify your doubts. Some of them they are asking the doubts by sending the screenshot. So this particular part is not clear. So learn, just you can send your doubts, you can call and clarify, but do study and I'm going to see you again in the next class with one more chapter, and definitely my best wishes for the coming test. Thank you.